All right, on 6.5, number 27, we're asked to solve this, and if it has no real solution, we're supposed to say that. So let's see what happens here. Now we notice that we've got two radicals, and we know that we never want to leave those on the same side of an equation. So what I'm going to do is I'm going to move this one over to the other side by adding square root of 3n plus 4 to both sides. Because remember, what we want to do is get one radical on each side. Here's my equal sign, right? These would cancel out and add to 0, and this would leave me with 2n minus 5 on the left-hand side, and on the right-hand side I'd have 2 plus square root of 3n plus 4. What that did is that put one radical on each side, and I always want to do that if I have two radicals. Now what we've kind of found out is a lot of times when this happens, I got to square both sides, clean up the mess, and then move the remaining radical by itself and then square both sides again. So it's a longer process, okay? And that's what's going to have to happen here. We're going to go, okay, I got one radical by itself over here. The other side's going to be a mess, but I can't help it. I'm going to square both sides. On the left-hand side, the square root of 2n minus 5 squared is just going to be 2n minus 5. And over here, we're going to have to say, oh, that means I'm going to have to distribute all this, or we can call it FOIL if you like calling it FOIL. So there's two copies of it. So it would be 2 times 2 is 4. 2 times square root of 3n plus 4 is 2 of those things. But when I do this distributing, there's 2 more of those things. That adds up to 4 of those things, those 3n plus 4s, okay? And then if I do the 3n plus 4 times 3n plus 4, that's 2 copies of that. That means that's just 3n plus 4. Let's clean that up now. Okay, so I have 2n minus 5. And then over on this side, I have 4. I can say, well, 4 plus 4 is 8. And then I have a 3n. And then I have 4 square root of 3n plus 4. All right, so we've already isolated, put one radical on each side and squared once. Now we need to do it again. We're going to repeat that process. If you look now, I still have this radical right here, and I want to get it by itself. So I'm going to move everything over to the other side. Okay? In order to move it, let me subtract 8 from both sides. I'm just going to subtract them all at once. I've got a plus 3n, so I'm going to move that to the other side by subtracting 3n. Okay, what will that give me? That gives me a little further. 2n minus 3n is a negative n, and then negative 5 minus 8 is negative 13. These cancel out and add to 0. And I've got 4 over the square root of 3n plus 4. Okay, I still need to get the radical by itself, because in a minute I'm going to square it, but I want it all by itself. So I'm going to divide the 4 out of both sides, and that means everybody over here gets divided by 4. You know what, though? It might be better if I just wrote one fraction bar there. Here's why. If I do it that way, I don't have as much to square. I've got one fraction, and then over here I've got the square root of 3n plus 4. This is going to make it a whole lot easier, I think. Okay, now I've got the radical by itself again. So I'm going to square both sides. Okay. If I square both sides, I get 3n plus 4, and on the top, this is negative n minus 13 times negative n minus 13, and on the bottom, 4 squared is 16, okay? Let's go ahead and multiply out what we have here. This is negative n times negative n is n squared. Negative n times negative 1 is plus n. Oh, no, that's a 13, isn't it? Sorry. Negative n times negative 13 would be plus 13n. I'll have another plus 13n here. And negative 13 times negative 13 is plus 169. All over 16 is equal to 3n plus 4. Right, we know that these two things can be added together, and that gives us 26n. Okay, we've still got some cleaning up to do, don't we? One thing I could do is I could multiply both sides by 16 to clear the fraction off. I could also, another thing I could do, we make this into a fraction and cross multiply. Here I'm just going to do this. I'll just clear the fractions by multiply both sides by 16. I could do it either way. I'll just do it this way this time. Most of the time I do a proportion. So you got to multiply that side by 16. That 16 goes up there. I just can't write it. That 16 and that 16 would cancel out. That would leave me with n squared plus 26n plus 169 is equal to, now I'm going to have to distribute that 16 times both of those numbers. As a matter of fact, most of us would rather see it written like this. Okay, 16 times 3n would be 48n, and 16 times 4 would be 64. Now I got a square here, so in order to solve this, what I'm going to have to do is get all the terms on one side. So let me subtract 48n and move it over here, because we need a 0 on one side if we're going to try to factor or use the quadratic formula. I also need to move the 64 over here. Remember, when I do that, that makes 0 plus 0, which is 0. Let me subtract 64 over here. Alright, so that leaves me with n squared, let's see, minus 22n plus 105 is equal to 0. So I'm thinking, okay, what can I multiply to get 105, and at the same time it adds up to negative 22? Well, let's look at 105. That's what, 5 times 21? That's 3 and 7. Let's see if we can figure out how to factor this. Okay, it looks like it would be 15 times 7. If I made this a negative 15 and a negative 7, that would work. So I would have n minus 15, n minus 7. So if I set each factor equal to 0, I'd get n over here. The first one would give, if I add 15 to both sides, I get n is 15. If I add 7 to both sides over on this other one, I would get n equals 7. So it looks like we have two answers. It looks like we have 15 and 7. But we need to check those out. And remember, we could put them on the calculator to check them out. I'm going to check them out on the next page. So we're checking out 7 and we're checking out. Okay, let's plug in 7 first. Alright, that would be the square root of 14 minus 5 is 9. Okay, minus the square root of 21 plus 4 is 5. So that's going to be 3, I'm sorry, 21 plus 4 is 25, duh. 3 minus 5 is negative 2. That didn't work out. That's not equal to 2. So our 7 didn't work out. Let's check out our 15. Square root of 2 times 15 minus 5 minus the square root of 3 times 15 plus 4. Let's see what that's equal to. 30 minus 5 is 25. Square root of 25 is 5. Okay. Over here, 45 plus 4 is 49, and the square root of 49 is 7. I get 5 minus 7 is negative 2. That's also not equal to 2. So guess what? We went through all that work, and there are no solutions. As a matter of fact, if you put this on your graphing calculator and put the left-hand side on one y equal, and then the right-hand side on another y equal, and you looked at them, they shouldn't cross anywhere. That's one way we could have known there was no solutions, but you'd still have to show all this work to prove your case, okay? Okay, now we got 3 radicals. The fun never ends. The more radicals we have, usually the more times we have to just kind of keep squaring. All right, I can't do anything about getting rid of a lot of radicals, so what I'm going to do is just basically start off by squaring both sides, because at least one of the radicals is by itself on the right-hand side. Well, on the right-hand side, that's the easier one. Square root of x plus 3 squared is just x plus 3. All right, over here, if I square it, and that's the square root of x plus the square root of 3 times the square root of x plus the square root of 3. Okay, hard to read, but at least hopefully you're listening. All right, well, the square root of x times the square root of x is x. That would be square root of x times square root of 3 is the square root of 3x. We could put it under a radical, but then I get another one here, so if I add them together, there's 2 of those in all, and then the square root of 3 times the square root of 3 is 3. So this is what I have. Now, at first it looks like you're going to have to do a lot of work, and your kind of thinking is this: get the radical by itself. So let's start doing that. Let's start getting that radical by itself. Some funky things happen here. Nice things happen. If I subtract x from both sides, those are going to cancel out. If I subtract 3 from this side, those are going to add up to 0 or cancel out. I'll just say, I'll put the 0 there now because I need it, right? So I get 2 square roots of 3x is equal to 0. Oh, wow, this worked out a whole lot better than I thought it was going to. Now if I want the radical by itself, I could divide both sides by 2. Well, 0 divided by 2 is still 0. So I get the square root of 3x is 0. And then if I want to solve it, I've got the radical by itself. I'll just square both sides. And the square root of 3x is just 3x. And 0 squared is just 0. Oh, wow. If I divide both sides by 3, I'll have my x all by itself. And what is it? X is 0. That's our answer. On number 33, we get a right triangle, and they tell us it's an isosceles right triangle. And if you look at it, I hope you remember something from geometry. This is a 45, 45, 90 triangle. That's what an isosceles right triangle is a 45, 45, 90 triangle. And so they're asking you to do two things here on 35. I don't know why I put 33, 35. They're asking you if the perimeter is 10, find x. Okay? Well, how do you find the perimeter of a triangle? You just add all the sides. So it would be x plus x squared root of 2 is equal to 10. Okay? Now, if you remember, we could simplify this. Would be 2x plus x squared root of 2 is equal to 10. And I want to get the radical by itself so I could square both sides. So let's just subtract 2x from both sides. It's going to be x squared root of 2 is equal to 10 minus 2x. And then let's do this. Normally I would divide both sides by whatever's out front, but since we want to get, I've got, the problem is I've got an x and I got a radical. Well, I want to get rid of that radical, but I also would like to solve for x. Here's what I'm going to do here, which is a little different than what we've done before. I'm going to go ahead and square both sides now. That x squared would give me x squared. And then square root of 2 squared would be 2, so that whole left side ends up being 2x squared. And then this is 10 minus 2x times 10 minus 2x. Now this might be a mess, okay? And I may not be able to finish it just out of time constraints. But what you would do is, let's go ahead, we would multiply this out and you would get 100 minus 20x minus another 20x would be minus 40x. And then minus 2x times minus 2x would be 4x squared. Ooh, I've got squares, so let me move all the terms to one side. In order to solve this, and I'll leave some of this for you, you're going to have to, you end up with 4x squared minus 2x squared is 2x squared. And then you've got minus 40x plus 100 equals 0. We're going to have to factor that to solve it. The good thing about it is I could factor a 2 out, and that makes it x squared minus 20x plus 50 equals 0. And so all I got to do to finish solving it is, let me go to a new page, x squared minus 20x plus, oh, I can't because I'm at the end of this recording. I'll need to factor that. What multiplies to give me 50 and adds to give me negative 20. Unfortunately, this will not factor. So what we have to do to solve this is we have to use the quadratic formula. So we could back up here and take this and use the quadratic formula on it, and that's how you're going to get your solution. And it's going to be messy, I'll just warn you. Now on the B part, if it's the area, you would just say, well, that one's going to be easier because base times height here would be x times x, which would be x squared, and the area is 12. Well, all we got to do to solve the area part is square root both sides. And the square root of 12 is going to be, let's see, 4 times 3 would be 4 square roots 3. Am I missing something here? X times x. Oh, I'm sorry, the area formula would be 1/2 of base times height, so it would be 1/2 x squared is equal to 12. And then I could multiply both sides by 2 and get x squared is 24. And if you just solve that little equation, that'll give you x. I can't even fit it on there, but it's x squared equal 24. It would be what you need to solve in order to get the area, and you'd be done. Part B goes fast. Part A, quadratic formula, not so great, okay?